Welcome back. In this video, we're going to go over section 7.4, which is about factoring special products. As we saw with multiplication, we saw that we could multiply any couple of polynomials together using a variety of procedures. But also we saw that in certain cases, depending on the format of the two or the polynomials we're multiplying together, we could use some certain formulas to speed our multiplication. We'll see something similar here with factoring. At this point, we know how to factor polynomials, whether or not their leading coefficient is 1. And so we can see how to make this a little bit faster by recognizing some special formulas or special patterns. So let's see how this goes. Again, we'll begin by looking at the corresponding multiplications and work our way into the factorization. So let's start by multiplying x plus 7 times x plus 7. So if you wanted to use FOIL, like you can say firsts, outers, inners, and last to get x squared plus 14x plus 49. And then we saw when we did multiplication that there's a pattern that we can observe here. Half of 14 is 7, and 7 times 7 is 49. So that enables us to do those multiplications a little more quickly. Here's another quick example. If we wanted to make y plus 8 squared, this will be y squared plus 16y plus 64. And how you can do that so quickly is recognize that the number next to the y has to be 2 times 8 or 16, and then the constant in the back has to be 8 times 8 or 64. So once again, another example. If we wanted 2x minus 3 times 2x minus 3, in the front we'll have 4x squared, then a minus because we have negatives this time, and then twice the product of the two things we have here, the two things being 2x and 3. So 2x times 3 is 6x. If we multiply that by 2, that's 12x. And then in the back, we should have 3 times 3 or 9. So we did multiplications like that, and we had these perfect square trinomial formulas to help us get this done. What we're going to do now is basically just reverse that process to help us get factoring done. So let's try these two. Here we have x squared plus 18x plus 81. So if we want to recognize the pattern here, half of 18 is 9, and 9 times 9 is 81. So we could kind of look at that. Let me make that a little bigger, but not too big. We could look at this as x squared plus 2 times 9 times x plus 9 squared. And then relating this to the formula at the top of the screen, our a is like the x, and our b is like the 9. So this would factor as x plus 9 squared. Okay, and that's it. Of course, we could have done this in the last section, or in the section prior, actually. If I asked you, okay, what are two numbers that are the same sign, both positive, that multiply to be 81 and add up to 18, you're going to figure out that they're both 9 really quickly. All right, let's try another one of these. Here we have y squared minus 10y plus 25. So for this one, you could ask yourself, what are two numbers that multiply to 25 and add to 10? And pretty quickly, you're going to get 5 and 5. It's y minus 5 times y minus 5, or if you like, y minus 5 squared. So once again, we could observe the perfect square trinomial pattern. Look at this as y squared minus 2 times 5y plus 5 squared. Okay, and then once again, it follows the pattern. All right, so for some of these, especially with the leading coefficients not a 1, it's more easy to use the pattern than it is to use methods from the preceding section. So let's try that with this example. Here we have 4x squared plus 12x plus 9. So what I'm going to do is rewrite this so that it fits this perfect square trinomial formula pattern. So let's make a little more room here. There we go. Let's see both on the screen at once. All right. So we've got 4x squared. I want to try to make it look like that's one thing squared. That will be 2x squared in the front. And the 9, we'll look at that as 3 squared. So then if this is going to fit the pattern, that 12x has to be the same as 2 times 2x times 3. So 2, 2x, and 3. Okay, so 2 times 2x is 4x. 4x times 3 is 12x. So this fits the pattern we have up at the top of the screen. And so we'll have 2x plus 3 squared. Okay. That takes a bit of getting used to. Fortunately, we'll have plenty of chances to practice. Starting right now. So for this one, we have 9y squared plus 24y plus 16. And we want to make this fit a squared plus 2ab plus b squared is the same as a plus b squared. So we need to make it fit that pattern. So I need to figure out what the a is. So 9y squared is our a squared. So that will be 3y squared in the front. 16 is 4 squared. 24y needs to be like the 2ab for our formula. So this will be 2 times 3y times 4. 2 times 3y is 6y. 6y times 4 is 24y. So the purpose of all that is just to ensure that it fits the pattern. Our final answer is going to be 3y plus 4 squared. Okay, and that's it. Okay, here's one for you to try. 81y squared minus 72y plus 16. So take a minute and pause the video and then try it and restart the video and see how you did. All right. So, by the way, one of the things that can suggest to you that you want to try this versus any other method, there's two things. One is both 81 and 16 are perfect squares. You can't always rely on that, but that's a good hint. 81 and 16 are 9 squared and 4 squared, respectively. So when you start seeing perfect squares show up, you want to think about using this method with the perfect square trinomial formula. The other thing, or the other thing that would suggest this to us, is that if we tried this using another method, like trial and error or the PQ method, I would need to find two numbers and multiply to be the same thing as 81 times 16, which is 1,296, and add up to negative 70. Sorry, Zoom crashed again. So what I was saying was that if we're trying to do this using the other method, find two numbers that multiply to be 1,296, but add up to 72, that's too hard, really. So there must be another way. That other way is this perfect square trinomial formula. So this will be 9y squared in the front, and then we had a minus this time. And then in the back, we have 4 squared. 72y, that's going to be 2 times 9y times 4. Okay, 2 times 9y is 18. 18 times 4 is 72. So that fits the pattern. So we've got 9y plus 4 squared. And that's our final answer for that one. Okay, so we have some more examples. Let's try this one. What's new about this one is we have two variables in there. There's x's and y's. Also, once again, the numbers are really large. We have 36 and 49. And if you find yourself saying, okay, 36 times 49 is what, then you're already working too hard. Okay, 36 and 49 are perfect squares. So that suggests to me that I need to think of this thing as a perfect square. And it may not be, but that should be my first idea. 36x squared. All right, let's try that again. So 6x squared in the front, 7y squared in the back. In the middle, that 84xy should be 2 times 6x times 7y. Okay, so 6x times 2, that's 12x times 7y. 12 times 7 is 84, so yes, that works. 6x plus 7y squared. Okay. This way of doing it, or this type of factoring problem, there's not a lot of writing to do. You either kind of got it or you don't, without a lot of writing. All right, so let's try one more. Once again, pause the video, try this one yourself, and then restart the video and see how you did. All right, so I want to make this fit that perfect square trinomial pattern. 16x squared will be 4x squared. 9y squared will be 3y squared. And then 2 times the first thing times the last thing. That stuff in the middle had better be 30xy. So 2 times 4 is 8, times 3 is 24. So that didn't work, did it? So this isn't going to be a perfect square trinomial. Let me just double check. 16 square root is 4, 9, 3. 2 times 4 is 8 times 3, 24. Yeah, that's not a perfect square. So for this one, we do need to do it another way. So let's figure that out. That's going to be kind of, we'll have to be careful with it because, 16 times 9 is 144. That's relatively large. So let's go ahead and do this. The pick PQ and factor by grouping way as perfect square didn't work. 16 times 9 is 144. So we need two numbers that multiply to 144 and add up to 30. Okay, so I think that, well, they're the same sign in both positive. Numbers that add up to 30 and multiply to 144. So let's try 24 and 6. Let's see if that works. Now that's 144. Yeah, that's too big. Oh, that's right. Yeah, 24 times 6 works. All right, so this one, it didn't work out to be a perfect square trinomial, but we are able to factor it by grouping. So let's do that. So we'll have 16x squared. Let me make that thinner. And then 24xy and 6xy, and then 9y squared. All right, so let's see. 16 and 24 both have 8 as common factors, so we'll be able to factor out 8x. This will leave us 2x plus 3y. And then in the second part, we have 6xy plus 9y squared. We can take a 3y out. If we factor out 3y, this will leave us 2x plus 3y, which is what we needed. Factoring out the 2x plus 3y, that will leave us with 8x plus 3y. Okay, all right. And that one, that will do it. So it looked like a perfect square problem at first, but it wasn't in the end. Luckily, it wasn't too hard. Okay, so let's try another one. So we've got 8x squared y minus 24xy and 18y. So as always, we want to look for a common factor. I can see 8, 24, and 18 are all divisible by 2. Also, I can see there's a common factor of y in there. So let's bring out 2y. Maybe there's more. We'll see after that what's left. So factoring out 2y, this will leave 4x squared. So that's a good start. And then minus 12x. And then in the back, we will have 9. All right, so now that's starting to look like a perfect square because of the 4x squared and the 9 both being perfect squares. Okay, so 4x squared will be 2x squared. And then the 9 in the back will be 3 squared. So 12x, that needs to be 2 times 2x times 3. And let's check and see if it is. 2 times 2x is 4x. 4x times 3 is 12x. So sure enough, that fits the pattern. Don't forget the 2y that's out front. And then we'll have 2x minus 3 squared. And that will do it. Okay, so that was the perfect square trinomial pattern. The other one that we had seen when we were doing multiplication was the difference of squares or product of conjugates formula. So let me do just one multiplication just to remind you how this goes. If you had y plus 5 times y minus 5, if you want to use FOIL or some other method to get this done, you can. Otherwise, you could recognize that, well, the y's are the same, the 5's are the same, 1 plus 1 minus, that's a product of conjugates, or a difference of squares formula will apply, and you can just write y squared minus 25. So we're going to do that here, just kind of running it backwards to factor. So here, x squared minus 81, that will be x squared minus 9 squared. So this will factor as a product of conjugate binomials. We'll have x's in the front, and we'll have nines in the back. Okay, all right, so x plus 9, x minus 9. Notice once again that you could have done this a couple of sections ago if you look at this as x squared plus 0x minus 81. If I asked you what are two numbers that multiply to negative 81 and add up to 0, you might have said negative 9 and 9. Okay, and sure enough, that would do it. Okay, m squared minus 1, that's going to again be a pair of conjugate binomials, plus 1, m minus 1. Okay, we've got next 81y squared minus 25. So I need to look at this as a difference of two perfect squares. 81y squared will be 9y squared. And then 25 is 5 squared. So I'll have 9y plus 5, 9y minus 5. Okay, that'll do. Okay, here's one for you to try. Pause the video, try it yourself, and restart the video and see how you did. Okay, we've got 144x squared minus 9y squared. So I'm going to look at this as 12x squared minus 3y squared. And so we'll have our conjugate binomials, right? 1 plus 1 minus. In the front, we'll have 12x. In the back, we'll have 3y. Okay, 12x plus 3y, 12x minus 3y. Okay, all right, that looks good. Try to see if we could do more with that. We can do more by factoring out a constant from that. This looks nice, but if you, we should factor it completely. So let's go ahead and take the constant out. 12x and 3y are both divisible by 3. So let me factor a 3 out here. This will be 3, 4x plus y. We'll do the same in the next one. 3 comes out of this 12x, leaving 4x minus y. Okay, multiplication is commutative. So this will be the same as 3 times 3, 4x plus y. That's about y. X minus y. Right, so that's 9, 4x plus y, 4x minus y. All right, so that does that. Of course, back here, from the beginning, I could have factored out a 9. So maybe we should go ahead and show that too. So another way to do this would be to factor the 9 out first. Then that would have been 16x squared minus y squared. I didn't see that, to be honest. I didn't see that first. Probably easier to do it this way, so let me go ahead and show how that looks. We have 9, and then 16 is 4x squared. So we'll have 4x plus y and 4x minus y. I didn't happen to see that common factor of 9 at first. Probably easier to take care of it first rather than later. Okay. Couple more examples. Okay, so we have 169 minus a squared. For this one, the number is in the front. It's helpful to remember perfect squares for this. 169 is actually 13 squared. So this is 13 squared minus a squared. So this will be 13 plus a, 13 minus a. It looks a little unnatural to see the number in the front instead of the a, but that's okay. Okay. All right, a to the fourth power minus b to the fourth power. This one doesn't exactly look like squares. It looks more like fourth powers, but a fourth power is actually something squared again. Here's what I mean. A to the fourth power is the same as a squared, right? That's the same as a squared times a squared. So we're going to look at this as a difference of two squares. So this is a squared squared minus b squared squared. Okay, so you want to be able to kind of follow the pattern. So a squared squared, that's our a to the fourth power. B squared squared, that's our b to the fourth power. So then conjugate binomials. First thing was a squared. Second thing is b squared. And we should have a plus and a minus. Okay. A sum of squares doesn't factor with real numbers, so we're going to leave that alone. That will just be a squared plus b squared. But the a squared minus b squared will factor as a plus b, a minus b. Okay, and that'll do it. With factoring, like simplifying, you want to go all the way with it, factor until it can't be broken down any further. So that will be our final answer. All right, here we've got 7xy squared minus 175x. Here there's a common factor of 7 actually, and x. So let's bring out those both. 7x comes out. That will leave y squared minus 25. Okay, and then y squared minus 25 should be pretty clear. That's a difference of squares. We'll have y plus 5. Y minus 5. Okay, 8x squared plus 200. For this one, 8 is a common factor that we can bring out. That will leave us with x squared plus 25. And that's it. That's the end on this one. Using real numbers, we can't factor a sum of squares. All right, that takes us to the end of this video. We didn't quite finish this section. We'll do that in the next part. So in the meantime, let me know if you have any questions, and have a great day.